Alright, our first one, right here, says, draw pictures, make all answers accurate to the nearest tenth. So we're going to go to the tenth. So we're going to have to use our calculators, that type of a thing. Go to the nearest tenth. Now, the first one says, a damsel in distress is being held captive in a tower. Her knight in shining armor is on the ground below with a ladder. The knight stands 15 feet from the base of the tower and looks up at his precious damsel. The angle of elevation to her window is 60 degrees. So, how long does the ladder have to be? Draw your tower. And it's going to be a right triangle, because here's the knight. There's the damsel. There's the ladder. Now, what angle does the tower make with the ground? 90 degrees. Now, how far away are we from?
15 feet.
We're 15 feet from the tower. So there's 15 feet. Now, I expect you don't have paper yet?
Still figuring things out.
We'll figure them out faster. I expect you to draw and totally label a picture. So if anyone's looking at it, me, for instance, I don't have to try to divine whatever information you're trying to do. Now, it says there's an angle of elevation to her window of 60 degrees. Now, somewhere in this triangle, we're going to put that angle of 60 degrees. Where's it going to go? Is it going to go up by the damsel, or is it down by the knight? Alright, so I heard two people. Up by the damsel, down by the knight. Well, it says the elevation to the window. So, if we elevate to the window, the angle is actually going to end up right down here. So that's 60 degrees. And I need to figure out what my ladder is. So that's x. So what side is this? That's just where if the tower continued up, that's where the lady's at that the knight's trying to rescue. The angle of elevation is basically what the knight sees and how high up the window is from the knight. Now, since this is a right triangle problem, and I don't have three sides because I don't know how high the window is, but I know when it's a distance of 15 that I'm going to have to put the ladder at a 60-degree angle in order to get to the window. Well, since we're dealing with this angle right here, what is this side with relation to the angle? Is it the opposite side?
Adjacent.
It's the adjacent side. So I know that's 15. Now, what do we need? Now, the x is the hypotenuse, so we need that. So, now we think of which one are we going to use that has the adjacent and the hypotenuse with it? Cosine? Yeah, so we're going to use the cosine because that's the adjacent side and the hypotenuse. So that tells me that the cosine of 60 degrees is equal to the adjacent side which I know is 15 feet. I put the A there over H, just so I know. And that would be X. That's going to be how long the ladder is. Now we're going to have to solve this for X. The best way to do this is to treat it like a proportion. How do you solve the proportion? Now you can multiply both sides by x. That's one thing we could do, or you could do a cross product, either way. But if you multiply both sides by x, you get x times the cosine of 60 degrees is equal to 15. And now how do I still need to solve for x. So x is going to be equal to 15 over the cosine of 60 degrees. Now, there's going to be an issue with your calculator. And I don't want you making any changes to any settings on the calculators. And the issue is that most of your calculators are going to be in radians, which is a different way to measure an angle. So we need to worry about degrees and the cosine of 60 degrees. So we can set up 15 divided by, and then the trig button right here, you hit trig, we go to cosine. But now we want 60, but we want to put that in degrees. Over here, the button that has the book, if you hit Control Book, and I know you can't really see it on the screen, but there's a lot. Oh man, can't even see anything on the screen. Right here, on this first row, there's all these different symbols. This is the degree symbol right here. You could go over here and hit degrees, and basically you're typing in 60 degrees. You hit enter, and it's going to end up being 30. So x is equal to 30 feet. Unless you know what the cosine of 60 degrees is. Another way that you can get to degrees, which might be a little bit easier, is this button down here, the pi button. If you hit pi, and you set this up as 15 over the cosine of 60, you hit pi, and you have a lot of those same symbols, the degree symbols right here. Hit degrees, you get 30 degrees. Now the problem is, if you just did 15 divided by the cosine of 60 without doing that, you get a totally different number because the calculator is in radians. And the calculators are in radians because I have a couple classes that need the calculators to be in radians for that. And we can just put everything in degrees. It's a lot easier to put in, if we're working with 60 degrees, to put in the degree mark than it is to make it to convert to radians. So the calculator should be in radian mode. So if you end up with, if you did this and you got this answer of negative 15.7495, does that make sense that your ladder is going to be negative 17 feet long? No, it doesn't make any sense at all. So even that makes even less sense. So you want to make sure that you set these problems up and the answer that you get actually makes sense. All right. Now, number 2. Let's take a look at number 2. You're 200 yards from a river. Rather than walking directly to the river, you walk 400 yards along a straight path to the river's edge. So, say this is your river, and you're 200 yards. So this distance right here is 200 yards. And instead of walking straight towards it, you walk along a path that's 400 feet or yards to the river. And we want to figure out what this angle is. So we want to figure out what x is. Now we haven't done something where we're trying to figure out what the angle is. Now I'm going to show you how to do that. Now let's just set this up because this is another trig problem. We have our angle x, this is our path, and we figured out the distance between us that's where we're starting. We're going to walk that path. So we need to figure out what that angle is. Now, what is 200 compared to this angle? Is that opposite, adjacent, or hypotenuse?
Opposite.
Opposite. So I know that's my opposite. Now, that 400, is this opposite, adjacent, or hypotenuse? Well, the only two things we have left are the adjacent or the hypotenuse. Yeah, it's the hypotenuse. Because 90 degrees is formed right here. So I have opposite and hypotenuse. So if I think of katoa, yep. Sine of x is equal to 200 over 400. Because that's my opposite side, that's my hypotenuse side. So sine of x is equal to 1/2. Alright, when you want to find the angle value, let me start something up here and let me switch this over. I think this will be a little bit easier for us. So when you want to find the angle value, you need to use hold on one second here. The inverse trig functions. So in this case, if I want x, I'm going to have to do this. I'm going to have to use the sine that's to the -1 of 1/2. This is called an inverse sine. And I'm going to show you what that's all about in a second here. But let's go to our calculator screen. In a second. Now, if you click the trig buttons here, you have your sine, cosine, tangent, cosecant, secant, cotangent. Then underneath that you have all your inverses. So they're all there for you. So if you just hit the trig button, and you can continuously hit the trig button, it'll pop this up. And since we want the inverse sine, we want this. And we want 1/2, so I'll do this. But the problem is, if you get an answer that looks like this, does this look like degrees? No, because that would say that this is just an absolutely crazy type of small degree, and it's not like that. So what we need to do is we need to convert this to radians, and here's how you do it. I gotta find it. So give me 1 second here, because I always forget. It's not in degrees, it's in radians already, because everything is basically in radians. So, when in doubt, you can hit the book button, and if you go to 1 here, these are all the different things that you can do. You can type in degrees, or you can type in D, and this arrow with DD is going to give us degrees. So if you get something that doesn't look like it's in degrees, and you should look for this answer right here, and we got 30 degrees out of this, then type in the answer, and then you do the arrow DD. Now, let's see. No, it worked. It just ended up giving us an answer in radians. Well, this is a 30-degree angle, so it's like an angle that's like that big. So that kind of makes more sense that this would be the path going to the river, as opposed to an angle that's about that big. That would be basically the path is the river, and doesn't go too much farther than that. Now you could have done something like this. You could have said the sine of 0.5, and then if you hit Control Book again, there's the big arrow that we want, and then we would go DD, we got 30 degrees. No, that's why I'm showing it to you. So when you do that when you're using the inverse, so you can get an angle measure, but also when your calculator's in radian mode. And you can always check to see if your calculator's in radian mode by going home, going to settings, and then going to general settings, and the second part here says radian. Don't ever switch that to degrees. Because I have classes that need it to be in radians all the time, and all we have for what we do, we're not going to be using degrees that often. So if we're using a problem that needs to be in degrees, we can just hit that arrow DD after the problem, and it'll give us our answer in degrees. So we can, I mean, it's 3 keys for us as opposed to a lot of extra work for my AP Calc classes. So I want to keep the calculators in radian mode. Most calculators should be kept in radian mode, and then you work on making it into other things.